All right, so let's talk through the steps here. So simplify the radicals first. There's nothing you can simplify here, so you go on to the second step. Rationalize by multiplying the numerator and denominator by the conjugate of the denominator. So the conjugate is same two terms, so 2 and root x, opposite sign between. And we took the sum here, so we're going to multiply by the difference. And when you do that, you get a negative 5 times 2 minus root x. And then across the bottom, again, if you just square the first term, so 2 squared is a 4, minus the square of the second term, x. Okay, so this is one possible form of your answer. There's no way to, there's no common factors to remove from this. And so this could be an answer for this problem. Okay, now, what I want to go through and talk over regarding this problem has to do with recognizing alternate forms of correct answers. Okay, so one of the things that you guys are going to start seeing and will notice more often as you kind of just are exposed to algebra, algebra 2, precal, and all of that, is often factors that contain x's are written with the highest power of x first. Right? And they're usually written, again, individual factors are usually written with a positive leading coefficient. Okay, so what you have to be able to recognize is if this was a question on the final and you work through the problem, again, in just these couple steps here, and you got this is your answer. For each question on your final, there's going to be answer choices A, B, C, D, and E. E is always going to be none of the above. Okay, which means if you don't see this form as one of your answers, you might select none of the above. But there are possible alternate forms. They'll usually be very consistent with the factors being written with x first. Again, in standard form, the highest power of x written first, and then also with a leading coefficient that's positive. So here's what you have to be able to recognize from this problem. If I left my numerator just as it is, again, the root x isn't going to vary. It doesn't really matter if it's first or second, but the x in the denominator will likely be a term written first. So if we just switch the order of these terms, negative x and a positive 4. Okay, but then I also said that when they're written, they're usually written with a leading coefficient that's positive. So what would we have to do to both terms in the denominator here in order to get a leading coefficient that's positive? Factor out a negative. Okay, so if we factored out a negative here, we'd get a negative x becomes a positive x, positive 4 becomes a negative 4. Okay, and now you could cancel these factors of negative. And so this would most likely be what you'd see on your final as a possible answer for this problem. Okay, so these are equivalents here. If I was asking you to write in answers, so on the quizzes and stuff that you do online, either of these would work. However, on the final, you would miss the whole amount of points for this question if you put none of the above, because you worked through the problem and got this answer, and that form was not one of the choices. So you need to be able to recognize alternate forms of correct answers. Okay. Does that make sense? Again, it's just a heads up for much later, but I mean, it's likely that you'll see something like that. All right, what I want you to do is to try this final question for me, please. Okay, see if you can simplify this radical. All right, let's talk through this process. Step 1, simplify the radicals completely. They're both already simplified. Step 2, multiply the top and bottom by the conjugate of the denominator. So same terms, root x and 3 root 2. Okay, opposite sign between. So originally we had a subtraction, so we're going to change the sign. And when you do that, multiply across the top, we're going to leave it as factors. So root 3 times the quantity root x plus 3 root 2. And in the denominator, we're going to take the difference of the squares of those terms. So root x squared is just x, always a minus, and then 3 root 2 squared. Okay, so there's a couple ways to approach 3 root 2 squared. Okay, a common mistake that's made historically is to forget to square the 3 and to just think you're squaring the 2. And so you need to think of this one of two ways. Either square each individual part of this product. So think of it as 3 times root 2 squared, and then the square is going to apply to the base 3 and to the base root 2, which then gives you 3 squared, which is 9, root 2 squared, which is 2, or 18. So you get x minus 18 as your answer. There's no way to simplify this. It's already written in the standard form, which is x is written first with a leading coefficient that's positive. So most likely this would be the form that is the best form of your answer. Okay, now I said there is another way to kind of think of this. If you have trouble working with these, squaring a number that has both the kind of the component that's a rational number and a component that's irrational, what you might want to do is you might want to move everything inside the radical. So what we could have done is we could have taken this, the root 2 stays inside your radical. But if we move this 3 inside the radical, what number would it become? The square root of what number is equal to 3? 9. So if you moved it back inside the radical, it would become a 9, which would then give you root 18 squared. And here the index and power cancel, leaving 18. So you can do that either of those ways. Jake?
How come it couldn't simplify?
The 3 and the 18. Okay, so one of the other common mistakes that tend to be made at all levels, including calculus, students continue to make these mistakes in calculus as well, and that is canceling factors with terms. Okay, so think about what your answer looks like. So 3 times the quantity root x plus 3 root 2 over x minus 18. The question is, why can't you cancel this 3 with this 18? And the reason is, when you look at these, 3 is a monomial factor. It means you have a factor with a single term. So it can only cancel with other monomial factors that have multiples of 3, or can cancel with the factor of 3. This next factor is a binomial factor. It has 2 terms added together, but as a whole, that's one multiplying force. So you can only cancel this factor with another binomial factor that has the exact same terms, so root x and a plus 3 root 2. So there's no like terms for that to cancel, or like factors for that to cancel with. In the denominator here, x minus 18, it's 2 individual terms, but together it's a binomial factor. So it can only cancel with another binomial factor of x minus 18. So when you compare these, there's only 2 factors that have the same number of terms, and they're not like terms, so they can't be factored or canceled when you factor. Okay. You can't cancel a factor with a term of another factor. And like I said, that's one of the biggest mistakes that's constantly made and students make year after year. So the sooner you can realize what the rules are for those, the better it will be for you. So you'll avoid those careless mistakes.